the common equipment we have now for froth flotation is a mechanical agitator kind of flotation system. So where you have your grinding, you have your ball mill, you have your sag and all that this, and then you have the gravity separation that you can use a mechanical spiral classifier or a cyclone to separate. So you have the underflow and you have the overflow from the cyclone. So the cyclone is better off because it doesn't consume more space. It's smaller and also can do what your classifier can do and do it better off. So the overflow of the cyclone goes over to is one that is coming to your flotation cells, where you have your conditioner. The conditioner have an overflow. So basically, what what affects or your you getting a very good process in flotation is how you arrange. First of all, if you get the good flotation cells, that is the type that is very good that you are accustomed with, then how do you set up that flotation? Because there's a place I went to and the setup was so bad. So yeah, it had actually affected the output of that plant. They weren't recovering much and they were having a lot of issues, accumulation everywhere. So how you set up your plant also matters, is very, very important when you want to optimize, your plant settings. So that is one of the key things you have to bear in mind while you go into this. So you must make sure that an expert comes in to help you set up the plant in such a way that it will be very good. So this is an example of a flotation cell, and also you can see example of how the air channels are being put in place, how the air is being introduced into the cell system. So the reagents that are required, in flotation, you have what they call the conditioners, you have the floaters, you have the collectors, and also you have the activators. Now, if I can actually, go and try to highlight on them, the conditioners, some people call them conditioners, some people call them the modifiers. They are the ones that actually try to modify the condition of the pulp. What's the pulp? That is the mixture of your material and waste in the semi-liquid form. So these are the and then the conditioners, you have something like your lime, your sulfuric acid, so the balance of the pH of the whole system. So you have your collectors. Your collectors are, in chemistry, we call them your ligands. Okay, they help you to pick up those metals. They help you pick up those metals from the system. So, and you have the floaters. The floaters is a example of your floater is things like lime, fine limes. Okay, you have MIBC. The common one is MIBC. So they help to stabilize the fruits, all those bubbles that will form. It helps to stabilize so they will not be cracking and be falling inside the cell. So, because those bubbles are the one that's carrying the metals. So, sorry, and also example of your collectors, you have your what they call PEX. Okay, you have PEX, you have SIPS, sodium isopropyl xanthate. You have PEX, potassium ethyl xanthate. So you also have SEX, sodium ethyl xanthate. These are kind of collectors. So you have depressed two metals. You want to separate. You have to depress one and collect one. Then later on, you activate the other one, then collect it. So you can. That's the idea. So in lead and zinc, we collect lead first and depress zinc. Then we collect zinc later on. Okay. You have also the activators. The example of an activator is copper sulfate. Actually, if you only have one metal, you don't need an activator. But if you're dealing with two metals like zinc. So you have to activate that metal you actually depressed earlier on. So how do you actually put in these reagents? These reagents, how do you arrange them? It's also important where you apply them. It's very, very important. Okay, because there's a diagram here. Yes, go back, please. Yes, this diagram actually showed you a typical, point that you can actually put in your reagents, of which you can change them based on what you see in your field. Here now you can see that from the sheet you have put in things like zinc sulfate, it's a depressant time for your pyrites. Then you also added PEX and MIBC. So in some plants you see that all those ones they add it before grinding. That is before the bone meal, before where your feed is entering your bone meal. In some plants they add it at the exit of of the bone meal, where your materials are coming out from the bone meal. So it depends on which one is more effective. So you try all those things to see which one gives you a better product. Then you can actually take that. So that is reagent addition. So, and it's very, very important also that you monitor all those reagents, because it actually, affects your recovery. Too much of your reagents also have an effect. And if you're using less of those reagents, also have an effect. Why would I say that? If you have too much of MIBC, your floater, you have, you recover a lot, but the problem is that the grade of whatever you're going to recover will go down, because the MIBC will help you to pack a lot of things, both the metals and and those ones you don't want. So it will scrape a lot of them out. Okay, so let's look at the flotation equipment. Yes, we have talked about that. So, but things that will help you to understand the kind of machine that you actually use. If you go through this, you'll see that what is the ore characterization? What do I mean by that? What is inside the ore? Okay, how is the ore? How is the formulation of that ore like? So it to tell you which equipment is best for that kind of ore. So you also do a bench scale testing. These are pre-plant installation tests that you carry out. All those ones they do them. All these things here listed, these are things that you do before you start your plant, because they will help you organize the kind of plant you want to start up with. So you have the design. You also develop a design, because are you going to make a design that you require too much pumps? We all know that pumps now are very, very expensive. So most plants actually try to reduce costs. They arrange the plant in such a way that most of the this goes with gravity. So the slope, there are some slopes in such a way that whatever comes, the overflow of this goes to the other one through gravity. So there's no need for pumps. But in some places that you cannot do without, gravity doesn't work, then you have to introduce a pump. Okay, that is for that. Okay. Okay, we can actually skip this. These are types of flotation machines. We can skip these ones, and you can see, types of flotation machines here. There are a lot of them in the market, so you have to be wise and also do due diligence in before you go into that. So, what are the parts that you can see in a flotation cell? You just have a box, with demarcations. You call them cells. So in those boxes, you have a demarcation. You call them cells. So each cell have what we call the agitator. So the agitator is made up of a rotor and a stator. Okay, a rotor and a stator. That is what the agitator is made up of. So you have different kind of rotors and stators, because in some designs, you at the entrance of the cell, that is where the feed enters the cell. You have a head agitator that goes with a propeller, is different from the rest, because that one now have to create vacuum to be able to suck in, because your flow is going through using gravity. So that head doesn't go sucks materials in. So let's look at optimization in flotation. How can we optimize flotation? Particle size is very, very important. You have to understand the particle size. That is, particle size means how fine did my ball mill, grind the material that I'm doing? Is it too fine or is it too coarse? So we try to make sure that we have, our milling, we call it milling, doesn't go too fine. Because if you go too fine, you have slimy situation. So when it becomes a slimy situation, you lose your materials because the reagent won't be able to catch them because it's too fine. But if it's too coarse, you still lose your materials. So we use, a medium so that your milling will be around 75 microns to 40 microns. Okay, that within those range, so that's what you have to monitor. Always monitor your sieve and doing sieve analysis. So it will tell you about that. Okay, the kinetics, flow kinetics. You're looking at flow kinetics. It talks about what affects, the recovery of this from the cells. So there are a lot of things that actually, affect your recovery. You talk about the reagents. Also, you also talk about your agitation. So if you have a bad agitator, it won't go well with your cells. If you're also using bad reagents, it will affect your recovery. Okay. So what are the challenges in flotation? Yes, complex ores are very, very challenging, very, very challenging. And also water. Most plants are actually facing water scarcity, and it's a very, very and so recovery of particles. So there are still research is going on how we can be able to recover 100% all the ores. So what are the future prospects and research in? Yes, we are looking into nanotechnology is what is in vogue now. Nanotechnology. How can we be able to use it to optimize the flotation? So also AI, how AI can predict, because most of the things you do with statistics. So we are looking at AI trying to predict what will be the outcome, helping us to solve some issues that takes a long time for us to achieve. So these are most of the challenges, also sustainability flotation. So in conclusion, froth flotation is very, very good. It's very, very is the best so far now, and I try to encourage miners and investors locally to invest in this because it will help you recover your whatever you put in. If we can all go in using this technology, which is simple also to use, it can actually it will help us to go a long way. So and also help our GDP and our economy to improve. As my conclusion for this. Yes, I'm here.
Okay, I think Patrick is one of is the CEO of Polyguard Investment Limited, and he's been involved in lead and zinc somewhere in Benue. So I understand his concern over this, and I want whatever he's producing from there. Definitely, there should be lead, there should be barite. In his site, you have barite, you have lead, and you have zinc. So, is there a possibility of having one plant to separate all this? Separate lead, barite, and zinc?
Yes.
And what method do you think is best for that?
Okay. First of all, looking at the combinations, barite, from what I've seen so far, I think it's all about you just separate using mostly mechanical agitation and scrubbers. You separate them out. That one more of you don't go through flotation. But for lead and zinc, you can use flotation to separate them. So if I'm to design a process that can do that, first of all, the barytes, you have to separate the baryte first. So we can now, whatever, after separation, then the underflow of our separation from the barytes, now we can now feed them to our milling system, where we can mill for lead and zinc. Now, because you can actually do the reverse. So we first of all remove the barytes first, then take the underflow for lead and zinc processing, mill, then use our Froth Flotation, then separate that. So it's highly possible.
Okay. Thank you very much, and thank you for at least coming around after all the challenges to actually give justice to this. I appreciate you on that. I will look at it. I think other questions that have been raised here. People have Mike and Suleiman have actually done justice to that. This juncture, maybe I will need to call Dr. Amuda, if you're online, to maybe just thank some of the presenters, show some kind of appreciation, and conclude on this today's edition.
What an incredible journey it has been today as we explore details of lead zinc mineral processing. I hope you found this webinar as enlightening, as thoughtful as I did. On behalf of the Executive Director of MSEP, Dr. Mrs. Salau Lami, and indeed the MSEP team, I want to extend my gratitude to our discussants who have generously shared their experiences and expertise. Your passion and dedication to this field is truly inspiring, and we all benefited greatly from your knowledge. I also want to apologize to our audience for the little glitch in audio during presentation of Mr. Ikena. Please do bear with us. These fluctuations happens at times. So then I really want to thank our engaged audience. Your questions and participation has enriched the discussions, making this webinar a collaborative learning experience. So as we close this chapter, I want to remind you that learning doesn't stop here. Let's stay curious, and MSF promises to keep you informed. If you have additional questions regarding this webinar or the series of workshops we have been having over time, please do not hesitate to contact the event organizers. MSF consistently holds this sort of interactive learning sessions every last Monday of the month. So being October this year, these are 10th series this year. Once again, I'd like to thank everyone for your active participation, and we look forward to seeing you in very near future. Thank you.
Okay, Doctor, thank you. Thank you so much for that closing remark. To this end, please, if you have further questions, you can actually send it across a message. We can actually receive that even when we finish. You can even go on to sending your message using the box, because with the Zoom, even when we're not holding meeting, you can also interact with the hosts out of this, so you can actually send in your message. Also, please, you can send in your email if you require if you don't have your mails, but if you are joining on for the first time, it is very, very important you send in your emails. To then the slide will actually send to you. Then you can also send in your phone numbers. If this is your first time, we can also add you to our list. Also, we have an advocacy group now called MSF Mineral Advocacy Group, which is actually rising. We have a platform. There's a link to invite to the platform. If you also want that, you can also send in your name and your phone number. You can actually be added to the platform and also be verified. In that, you can actually keep in touch, like whatever we do here, we can also circulate it within our platform and some other awareness and information that are also coming. I thank everyone here today who have actually participated. Also, you can see we thank our sponsors. There are some individuals who are actually taking it on them to, from time to time, try to sponsor one of your programs. So if you also feel like you want to do one or two things to sponsor some of the programs and the workshop in schools, in universities, and also trying to move on to some level of advocacy in the mineral and in the mineral industry and sustainability, you can also contact us. As a corporate body, as a company, you can also contact us. So this is actually held once in every month, especially last Monday of every month by 12 o'clock to 12 to 2 every last Monday. I thank you all for your wonderful time.